for one of them, which is the easiest one, which is angle, angle. Okay, so here we go. Let's go ahead and get working on to these notes here. So our first shortcut to prove triangles similar to each other is if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So let's go ahead and label this triangle down here ABC. I'm going to label this triangle DEF. So this theorem tells me that if, let's say, angle A is congruent to angle D, so we're going to put little arcs there, single arcs. And let's go angle B congruent to angle E. I'm going to do double arcs up there at B and D. Am I trying, or sorry, B and E. There it is. So if those two sets of angles are congruent, then it must be true that the triangles are similar. So then it must be true that triangle ABC is similar to triangle DEF, right? Because of angle, angle. Technically, angle, angle is the same as angle, 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 right? Because the third angle theorem tells me that if I've got two congruent angles, then the third also need to be congruent to each other. Okay. So angle, angle, just need two congruent angles. It's okay if you have three, but I need a minimum of two for the triangles to be similar to each other. Got it? All right, so now where things get a little bit funky is when we throw in the sides, because sides are proportional. So shortcut number 2, side, side, side. If the corresponding side lengths of two triangles are, underline, circle, whatever you need to do, proportional, right? Proportional. They need to be proportional. Then your triangles will be similar. So let's go ahead and label again ABC. And I'll make the other one DEF. So now I don't have sides congruent anymore. That was back in chapter 4. Now we're talking about similar. So now I need my sides to be proportional. So let's say AB looks like the shortest side over there. So the length of AB divided by the length of DE should be the same as the length of BC divided by the length of EF, which should be the same as the length of AC over the length of DF. Right? So if I do this number over this number, so let's say smallest over smallest, middle over middle, largest over largest, and I do all those divisions and they all end up being the same decimal and they're proportional, then we could say yes, right? Then they are similar to each other. So triangle ABC is similar to triangle DEF by side, side, side similarity. Okay, so if you're given only angles, check angle, angle. If you're given only sides, check side, side, side. And then the third one is side, angle, side. So let's quickly make sure we remember side, angle, side. If I have angle 1, angle 2, angle 3, side A, side B, side C, which is the included angle between side A and C? 1. What's the included angle between A and B? Oh, I didn't realize how tiny that was. It was big on my screen. 2. What's the included angle between B and C? 3. Good. All right, so we've got our included angles. So that must be true for side, angle, side. So if an angle of one triangle is congruent to an angle of a second triangle. All right, so let's do some labeling again. A, B, C, D, E, F. Let's go B and E being our congruent angles. So put a single arc up there. So if we know that angle B is congruent to angle E, and then the sides that include that angle are proportional. So the side that includes angle B would be AB. So AB would have to be proportional with DE on the other side. would have to be equal to the other side that includes angle B would be BC over EF. So if this over this is equal to this over this, and I have an included angle, then they could be similar. So then triangle ABC is similar to triangle DEF. Okay? So you could imagine if we had to do full out 2-column proofs with side, 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 and side angle side, that would get a little bit complicated because we'd have to do proportions within our proof. We're not going to do that. We're just going to do proofs for angle, angle. But before we get to the proofs, let's make sure we can identify all of these different shortcuts. Okay, so flip onto the back when you are done with that. All right, so number 1, determine whether the following triangles are similar. If so, write a similarity statement and then justify it with the reason why. Okay, so do I have any angles shown anywhere in here? Whether I have degrees or arcs? No. So that eliminates side, side, or side angle, side, and angle, angle, which leaves me with side, side, side. So let's check, are all of my sides proportional with each other? The easiest way to do that is compare smallest to smallest, middle to middle, largest to largest. So what's the smallest on the left? 21. All right, 21 over 15. And we want to see if that is equal to, let's go to the middle. So 35 over 25. And see if that's equal to largest over largest. So 42 over 30. And it's just a matter of calculator work. So on my calculator, I'm going to do 21 divided by 15. And I get the decimal 1.4. 35 over 25, 1.4. Oh, I'm getting excited here. Let's see if it works for the last one. 42 divided by, yep. So are my sides proportional? Yes, they are. So check. So we're going to say yes, they are similar. Write a similarity statement. Okay, so triangle, I'm going to go PRQ. PRQ is similar to triangle P would match up with X, R to Z, Q to Y by angle, angle, similarity.
Side, side, side.
Oh, side, side, side. Thanks. Side, side, side. Yeah, we didn't do anything with angles there, did we? All sides. Side, side, side. Okay? If just one of these weren't 1.4, then I would just say no, they're not, right? Because my sides would not be proportional. Okay, we'll go with number 1. All right, let's jump to number 2. Do we have any sides given to me? No. So it can't be side, side, side. It can't be side, angle, side, which leaves me with angle, angle. Do you have 2 sets of congruent angles? Well, we have right now angle D congruent to angle G, right? Because those are right angles. What would be the measure of angle E? That would be 180 minus 90 minus 26.
Wait, aren't the angles the same even if the size changes?
Yes, the angles will always stay the same, even if the size changes.
So it is similar.
Right. So when I do this, angle E is 64 degrees, which does match up with H. So angle E is congruent to angle H, which technically then means C should match up with K, but that's just one extra step that I don't need because I only need a minimum of 2, because if I had the 2, then it's proven that the third will also be congruent. So we have enough information. So yes. So triangle CDE is similar to triangle C would match up with K, D with G, which E would then match up with H by angle, angle similarity. Okay. Good there? All right. Number 3. Do I have any sides given to me anywhere? Nope. So it can't be side to side, can't be side angle side, which means I'm looking for two sets of angles. Does everybody see the overlapping angles? You got the top one that I highlighted in pink, and then the bottom one I'll highlight here in purple. Maybe people can't see purple and pink. I'll make it orange. There we go. Does everybody see the two overlapping triangles? Yeah? All right, if I rewrote these separate, so triangle TCE, with this being 65 degrees, and then triangle PAE, with this being 65 degrees, do we have two congruent angles? I've got one, right? I've got T and P being congruent to each other, but I do have another one that's congruent. What do they both have in common? What property tells me angle E is congruent to angle E? Something that's congruent to itself. In the past, we were used to seeing it like this. Ah! The property gave me that. Source of are reflexive, right? So in the past, we've been using reflexive property with line segments. Now we're going to be using reflexive property with angles. So E is congruent to itself because of the reflexive property. So right here we have a reflexive property. Reflexive property. Just keep that in mind when we get to our proofs. So we do have two sets of congruent angles. We have the top one, and then we've got these 65s in common. So yes, we do have congruent or similar triangles. So yes, triangle TEC is similar to triangle PEA by angle-angle similarity.
I'm just wondering, could you also use the midpoint, but
Well, we don't know it's the midpoint for sure, because I could shift this down and that would still say 65 degrees as long as I keep it parallel, right? Because then your corresponding angles would be congruent to each other. So this does not necessarily need to be at the midpoint. That's a good thought. But that's what we're going to be going for proofs, right? If I know that this is parallel, if parallel lines, then corresponding angles are congruent, right? Because that's where we're going to be going with our proofs. We're going to be having diagrams with no numbers in them, but parallel lines and all other wonderful things, vertical angles that get us congruent angles. Okay? All right, number 4. Here I do have sides. Here I do have angles. Do I have a side angle side situation happening on both? Yes, I do. Okay, so I have congruent angles. Now let's check our sides. The smallest on the left is 21. Smallest on the right is 35. Largest on the left is 30. Largest on the right is 50. Are those equal to each other? So 21 divided by 35 is 0.6. 30 divided by 50 is 0.6. So yes, triangle XYZ is similar to triangle X would match up with G, Y would match up with D, and then J by side angle side similarity. And the last one, what do you think it is? Angle, angle. Where is the second angle? What do we call it? Starts with a V. Vertical. Good. Yep. So your vertical angles get you the second set. So yes. Triangle, if I go ABE, is similar to triangle A, matches up with C, B to B to D by angle, angle similarity. Okay. All right, we're going to pause there from our notes and jump onto Desmos and work through some Desmos practice, and then we'll come back and finish up the proofs. Proofs for being able to prove triangles similar to each other. The only theorem that we are ever going to use is going to be angle, angle. we're never going to use side, side, side in a two-column proof, and we're never going to use side, angle, side. So that means all of your end games will always be angle, angle. So you should be able to get your given, and you should be able to get your end with an angle, angle. It's just the filling in the in-between, right? Can you do that? All right. Sorry I was not nice enough and gave you guys your T-charts there for you, so you can go ahead and set one up for yourself. So remember, we have statements on the left, reasons on the right. First line is always our given. In this case, we were given angle S is congruent to angle W, given. And I need to prove that my triangles are similar to each other. So in order to prove that the triangles are similar to each other, I need two congruent angles in order to use angle, angle. Right now I have one. Where's the second one? Vertical. Now think back to what our rule of thumb was for our template when doing congruencies for triangles. Look for vocabulary or symbols, right? If I don't have any of those, then I'm looking for either the reflexive property or vertical angles. In this case, we do have vertical angles, but remember your reflexive property now is going to look something like this with those overlapping triangles. It's no longer going to be the diagonal down a parallelogram. So line 2, let's name those congruent angles in the middle. So angle SUV is congruent to angle WUT. If what, then what? Good. If vert angles, then congruent. So now I have one set of congruent angles, a second set of congruent angles, so now I'm done. So line 3 is my prove line. So now I have enough information to say triangle SUV is similar to triangle WUT because of angle, angle similarity. Easy enough? Okay, all of these will end with angle, angle. We're not going to do any of the other options. So you should be able to have your given, you should be able to have your end, fill in the in-betweens. Which really, if you're not given a set of angles in your given, then that means you're going to have two statements in between your given and your finalized. So at most, maybe you'll have a 4-line proof. Though I guess technically if they gave you perpendicular, then you could do if perpendicular, then right angles, if right angles, then congruent. So that might add a little bit more. So maybe that would be a 5-liner. All right, number 2. Set up your T-chart. Statements on the left. Reasons on the right. Given. What are we given here? Okay, so JK is parallel to GH. All right, so what do parallel lines give us? Something. If parallel, then some type of angles will be congruent. In this case, corresponding angles will be congruent. Right, with angle 1 and angle 2. Okay, so let's name them. How do you name angle 1 up there? That'd be angle FJK is congruent to angle FGH. Okay. I need a second set of congruent angles. Where is it? Sean? On the top. So angle F is congruent to itself because of the reflexive property. Now I have 1, 2 sets of congruent angles. So now I can say my triangles are similar because of angle, angle. So now just rewrite your prove line for line 4. So triangle JFK is similar to triangle GFH by angle, angle similarity. Okay. You can imagine that when we do like side, 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 side angle, side, where you have to do the proportional sides, that gets a little bit funky, right? Because we don't have as nice of if-then statements there. All right, and then the last one, got parallel again. Statements, started over too far. Reasons, given, MQ is parallel to OP, given. Okay, so now if parallel, then what type of angles do we have? Blank angles are congruent. Yeah, here they have alternate interior. Now, we can do all sorts of options with this. We could do both sets of alternate interiors and call it good. So I could do, just watch for a second, I could do Q with O and M with P. And then just ditto mark line 4. That might be the easiest, less writing. Or I could just pick one of them. So maybe I just pick Q and O and then do vertical angles for my second. And make vertical angles be my line 3. And then I have both. So it doesn't matter. What do you guys want to pick? You want to go both alternate interior or you want to do alternate interior and vertical? We don't care? All right, I'm going to go both alternate interior then, just so I can ditto mark it. So let's go angle Q, congruent to angle O. And then I'm going to do angle M, congruent to angle P, and just ditto mark. Oops, I forgot to put alt int in here. So if parallel, then alternate interior angles congruent. And then I have two sets of congruent angles, so I'm done. So triangle MNQ, similar to triangle PON by angle similarity. Does everybody see how I could have went with one of these and then do vertical for the second one?
Yeah.
Okay. All right, so that concludes your notes.